All right, what is up, everybody? Tom McGurl here with yet another part in our series, the Learn Rust Live series we've been calling it. I'm excited to be here. If you've been following along, we've been going through the Rust book. We've been going through Rustlings exercises. We thought we'd finish last time. We did not, but we might finish this time. We might just skip some. Who knows? We might finish. Clam Watson's in the chat already with the poggers. Love to see it. Love to see it. If you're watching on YouTube, thank you for joining. I appreciate it. If you've subscribed, thank you for joining. It's been really awesome seeing all the subscribers coming in and seeing all the views. I'm happy that people are enjoying the stream and really great comments. Keep them coming. I'm happy to answer any of your comments. So thank you very much. A lot of comments on my editor theme. It's Monokai Ocean for those who are wondering. But yeah, thank you for watching. Thank you for subscribing. If you're watching on Twitch, thank you for the follows. Thank you for the views. It's all really appreciated. Started doing this a few months ago now and have been having a lot of fun with it. Again, we always stream on Twitch, twitch.tv/TomMcGurl, 9 p.m. Eastern Time to 11 p.m. Eastern Time. We've been doing that every Tuesday. Also producing a little more one-off content. There will be a lot more of that to come as we enter into winter break. And I'm thinking about adding another day of the stream. I'm thinking it's going to be Wednesdays, but we'll see how things go. And it may not be every Wednesday, but we'll try to add a little more variety. We're on the path to becoming Twitch affiliates, so pretty excited about that. So come a long way. I've been having a lot of fun. Hope you have too. As always, gotta plug it. If you've missed any of the streams, don't worry. All the content gets posted on YouTube after the stream. So usually the day following, so you'll usually see it up on Wednesday, the following Wednesday. Up here you can find all the previous parts where we've gone through all of the book up to chapter 10. We'll be starting maybe chapter 11 today, which is on testing. But we've covered things like structs, enums. We've done collections, hash maps. So we've learned a lot about Rust, and we're on our way to becoming Rustations and actually using this in a project. And I believe, if I'm not mistaken, chapter 12 of the book is actually going to have us build a small project. So that should be really exciting. We can flex those muscles, use what we've learned. Now, before we jump into that project, we decided to take up the Rustlings exercises. And so the Rustlings exercises can be found here on this repo. And they're just little exercises. They run tests, and you have to fix your code until the tests pass. And that's been a really good way for us to flex those muscles of things that we learn, right? And use it a bit. Because if we don't use it, at least in my case, I tend to lose it. So got to keep going and practicing things. And Rustlings has been a really awesome practice. So shout out to anyone who's contributed to the Rustlings project. It's been fantastic. We got a bunch of contributors here. You can see Carol Nichols. She's also the author of the book we've been going through, or co-author. So been really, really fun going through that. You can find that all here. We've also got some one-off content. We got a video on building a development environment for Rust with Docker. So if you don't want to install Rust on your machine, or you want a repeatable Rust environment for development, check that video out. Probably add a little more to that into the show notes, just in case people want to go a bit further with it. Other stuff we've done, we built a backend serverless API with AWS Lambda. That was a lot of fun. We used DynamoDB for that, TypeScript and Node.js, and we used S3 for some image storage. So that was a lot of fun. Before that, we did a React Native app. So a little mix of everything. Started doing Rust because I was interested in having a systems programming under my belt that wasn't C. You know, I was kind of a little bored with C. I'd done it a lot in college. It's definitely useful, but Rust has been really exciting. So happy to be doing that. So again, we're going to continue with Rustlings today. If you want updates when I go live, you can follow me on Twitter, where I tweet stuff. I'll tweet any of the content I put up. You can get posts there. You'll notice what's going on. And I'm also posting everything on my GitHub. So the only thing that's not up here yet is the Rustlings, and that's because we're going to wrap it up, and then I'll move it to a separate repo and push it up here. But everything else is here. You can find our Learn Rust Live, where we've been going through the book. The repo contains all of the code we've written so far while going through the book, all of the exercises we've done, and so forth. We also have the serverless API repo for that AWS Lambda serverless API. Check that out if you're interested in that. Super cool stuff, really easy to set up. Just follow that video, pretty straightforward. We have our React Native Brewbook app, and this was actually the backend for that app. So this app's a React Native app with TypeScript. If you've ever thought about getting into mobile development, React Native is a fantastic way into that. And it's using Expo, so everything's really simple. You can get apps on the App Store relatively quickly. And I'm sure there'll be more content about that soon, because I really enjoy React Native. It's a lot of fun. So yeah, check that out. But today, Rustlings, we're going to continue. We're going to pick it up. All right. So let's jump in and where we left off. Let's go over that a little bit first. So let me pull this up here. Get rid of this. Pull this up. All right. So where did we leave off? So if we run Rustlings watch here, you can see all the stuff we've completed. Also, you can kind of tell by the folders we've modified here on the side which ones we've completed. So we haven't done conversions yet. We haven't done threads yet. And I think there's probably a few quizzes maybe we haven't done. So we've done a good amount. And we might finish today. We're now in the territory, by the way, of Rustlings where we're doing some stuff that we haven't yet learned in the book. So if it happens that we can't complete something, we'll use the hints. If the hints aren't enough, we'll maybe skip those exercises and hold off until we get to that chapter of the book. This way we're not kind of guessing at stuff, and I don't feel like I'm learning that much if I'm just guessing, so I'd rather get to that chapter first. So threads might be one of those cases. We have not covered threads yet. We were able to get past some of the exercises that involve threads, but I took a little peek at this one, and it's a little more difficult. We'll pull it up and we'll check it out, and then we'll try going on to conversions. If we finish early, we'll jump into chapter 11 of the book, which is going to be on unit testing, which we've seen a little bit about, but we'll get more into that. So let's kick it off by running Rustlings watch. So these are all the ones we've done: variables, if, functions, quiz, primitive types, structs, strings, enums. We did a quiz, some tests, modules, collections, hash maps. We've done vectors, we've done macros, move semantics, which is all about borrowing, errors, error handling, option type, result type, learned about Clippy. We've done some generics and traits. So we've done a good amount. It's been a ton of fun. But now we're on to threads. So what's going to happen here is it's going to tell us which one is erroring out. So in this case, it is threads 1. So what we do is we open up that file. Let me just close all these ones, get them out of our way here. Let's get rid of this, get rid of this, get rid of this. All right, let's open up threads 1. So just so we can see what we're getting into, and then if we can't figure this one out, we'll skip it. We have not yet learned threads, and maybe we'll come back once we have. But let's just take a look, see what we can decipher from the hints. So it says, make this compile. Execute Rustlings hints threads 1 for hints. The idea is that the thread spawned on line 21 is completing jobs while the main thread is monitoring progress until 10 jobs are completed. If you see 6 lines of waiting and the program ends without timing out when running, you've done it. Okay, so again, on line 21, there's a thread spawned right here. So the thread spawned on line 21 is completing jobs. So in this case, it looks like we have 10 jobs. All the job does, it's a fake job. It's not doing anything. It's just going to sleep for 250 milliseconds. So very, very fast, right? And then it's marking the job as complete. And then on line 10, so line 21 is completing jobs while the main thread is monitoring progress until 10 jobs are completed. So the main thread here is monitoring jobs right here until they're completed. So here we have our thread spawned, a loop from 0 to 10. That's a range, so it's going to loop 10 times, sleep, and mark completed. And this is just going to listen for when those jobs are completed. And while it's less than 10, it's going to print waiting. And it's going to sleep and keep waiting. And then it should just end. And it says that here. It says we should see 6 lines of waiting and the program ends without timing out when running. All right, so if we run this here, we see that the first thing it's complaining about is it cannot assign to data in arc. And so here we have status shared jobs completed plus equals 1 cannot assign. And so that's on line 24. So here this assignment is not possible, and it's going to tell us a little bit about why. Help. Trait. Deref mute is required to modify through a dereference, but it is not implemented for standard sync job status, arc job status. So what it's saying is there's a trait called deref mute, and it's required to modify through a dereference, but it's not implemented for arc job status. What do they mean by that? Well, status shared is a clone of status, which is of type arc job status. And it's saying that it doesn't have the trait deref mute. And so we can't, that trait is required to modify the thing. So we can't use this potentially. We have to do something to this to give it that trait or use something else that has that trait. So what I would first do is I'm going to kind of just copy this part, not the job status part, because that is unique to our app. That's a structure unique to our application. But what I'm going to do is I'm going to copy this error, and we're going to go just kind of see what the internet says and see if we can find anything, because this is how we would do it, right? We'd see, not that. That's my Twitter. Get out of here. Let's copy this. Wait, why is my copy not working? Hold on. All right, let's see. All right, so we have our ARC documentation. So we can definitely look at this. So the ARC documentation, we looked at this before we were doing ARC, but so it says here, ARC is a thread-safe reference counting pointer, and it stands for atomically reference counted. So it's an atomically reference counted structure. And if we look for the deref mute, let's go here. What is this doing here? So here we have, this is an example taken from the mutex documentation. So they're using mutexes here, which we have not learned about yet, but are kind of familiar with from other languages. So what we'll do is let's use our hints. So to use our hints, we just do Rustlings, hint, and then threads1. There we go. All right, so now it's going to print out a hint for us. So let's see what this says. ARC is an atomic reference counting pointer that allows safe shared access to immutable data. There you go. That's one problem right there. We're trying to mutate that data. It's immutable. But we want to change the number of jobs completed, so we need mutable data, right? So we'll need to use another type that will only allow one thread to mutate the data at a time. Take a look at this section of the book. So let's take a look at this section of the book, just like they said. All right. So here it's jumping us right to a particular piece, and it says, fortunately, ARC over generic type T is a type like RCT that is safe to use in concurrent situations. The A stands for atomic, so it's talking about what ARC is, atomically reference counted type. Atomics are an additional kind of concurrency primitive that won't cover in detail here. See the standard library documentation. Okay. But it says here, you might then wonder why all primitive types aren't atomic and why standard library types aren't implemented using ARC-T by default. The reason is that thread safety comes with a performance penalty that you only want to pay when you really need to. If you're just performing operations on values within a single thread, your code can run faster if it doesn't have to enforce guarantees atomics provide. So here it's saying, let's return to our example ARC-T and RCT have the same API. So we fix our program by changing the use line, the call to new, and the call to clone. So none of this seems relevant, but I see here that we do have a similar type thing going on here. And so they have a counter, arc new, and this part's different, mutex new. And so I'm assuming mutex is from our hint, the type that's going to allow us to mutate the object and to allow a single thread to take a lock on that, right? So it can mutate it. So here we have a mutex. There's a counter. They're cloning, thread spawn, and they're mutating num. So you can see here, just like we were doing where we were trying to mutate, in our case, let's pull it like this. Let's do this. Let's pull this down here. Oh, where do we go? Let's make this go here and make this go here. And we'll kind of compare a little bit. So I think that would be useful. Now let's toggle that. Okay, so here we have our declaration. It's just arc new, and the type T that we're generic over is, in this case, a job status struct. Here they have arc new, and the type they're generic over is an integer, but they're using mutex new. But they're doing something similar, right? Here they have a loop where they create a counter by cloning it. We're calling status clone instead. And then they're actually able to mutate the value by getting a lock from counter, unwrapping it, and then they can mutate it. So let's try that. Let's see if we can do that. So what we're going to do first is we're going to try to use mutex, first we have to import it, and it comes from the sync library. All right, and so we'll create a new mutex, and our mutex will be generic over the job status now. Okay, so now we have arc new, which is generic over a mutex. The mutex is generic over job status. So we have status, and I'm gonna copy what they have here. Instead of using status clone, I'm gonna do, and again, not totally sure what this is doing because we haven't yet gotten to this part of the book. And even though we're reading it now, it's kind of out of context. So once we get here, I think it'll make a lot more sense. But let's just see how far we can get. And if we can't pass it, we'll skip it for now. We'll comment it out and skip it. Clone, and we'll take a reference to it, status. All right, so let's see what happens now. So let's run Rustlings, and let's just run the specific thread one. Rustlings, run threads 1. And let me go ahead and make this full screen. Oh, not that. There we go. Okay, so it says here, cannot assign to data in an arc. So still the same thing. Let's see, did I save? I probably didn't save. I didn't save. All right, so let's try that again. Okay, so different error. That's a good sign. No field jobs completed on type standard sync arc. And so here you can see we're trying to access jobs completed. And I think the reason for that is because we need to actually grab a lock before we can access the value. At least that's what I'm getting from here. I'm not sure what unwrap is doing, but let's try doing that, what they're doing here. So here they create a mutable reference to, or they actually set this as a mutable, new mutable variable. So we'll do the same thing. So we'll say, let's call it mute s equal, and we'll do, in their case they are doing counter.lock. What we're going to do is we're going to grab status shared.lock, grab a lock on it, .unwrap. We'll try this. Then we'll have s, and what we'll do here is we will use s.jobs completed. And let's try running that. All right, so that part, we got past that part. And now what it's saying is no field jobs completed on this version, because here we're using while status jobs completed. So let's try changing status here to reference this. Now, the problem is this is created within the scope. And so the problem there is that I don't think this will have access to it. So let's try moving this out. I don't see a reason why we need it within this scope. So let's try moving this here. And what we'll try doing is just changing this to S. I don't know if this is going to work because, again, I'm worried because I think the lock has to be inside the thread. Let's see if it blows up. Yeah. So cannot send between threads safely. So I think this has to be done. Our lock has to happen within our thread. So let's see if we can. So here we're able to mutate S. We're able to up that jobs completed. The problem is we can't do anything here. So let's see if what happens if we just use status shared here. And let's clear this out. And let's run that again. Ah, so unknown field. Now, I wonder if it's because we have to lock unwrap again. Let's try that. Let's clear that out. Try running it again. Okay, so a little different error here. Borrow of moved value status shared. Let status shared arc clone. Move occurs because status shared has type arc, which doesn't implement the copy trait. So it gets moved because it doesn't implement the copy trait. It's not like a primitive, right? Value moved into closure here. So here the value gets moved into the closure. Variable moved due to use in closure. So it gets used in the closure here. Value borrowed here after move. So it's been moved, so it can't do anything with it here. So let's try to prevent moving it by maybe passing a reference. So if we have status shared out here, what we can try to do is, what if we got a reference to status shared? I don't know how this is going to work with the lock, but let's see if this will, let's see what this complains about. Okay, so no change there. So let's see, how can we, maybe we have to use arc clone because there's no copy trait. We could potentially clone it, but the problem is if we clone it, what I'd be worried about is, well, let's see what we can do here. So this is very useful. Variable moved due to use enclosure. So it's being used here, and so it's getting moved because this closure. I wonder if we can actually just have this closure free it up. That's another option. How can we do that? Let's see. Mute S, status shared, lock, unwrap, thread sleep. We're mutating jobs completed. We can potentially have this thing. We can move this out into maybe a separate function. So this thread is being spawned. It's doing this work. It's mutating status shared. So I don't think this will actually work because it's not a reference. S is mutable, but it's it might be able to take a lock on it. Let's see what happens. I have a feeling we have to declare S outside. What happens if we just do S here? I'm sure it's going to be undefined. Let's try it. Yeah. So S is not found in the scope, and that's because it's defined within this scope. So what I'm thinking we could do is, what if we tried instead of using status shared here, it gets borrowed, right? What if we could I want to try getting a mutable reference to this. I'm not totally sure, and I'm tempted to kind of skip this just because we haven't gone over it in the book, and I don't want to guess at it and then not have a good understanding of what's going on. I feel like we could probably game it to get it to the point where it's successful, but I'm thoroughly not understanding it because I just haven't gotten to that point. So why don't we do this? I'm going to skip this one. I'm going to just comment it out. And so it should compile because there's nothing to compile. Or maybe it'll just say there's no main, but let's see. And we'll come back because I feel like even if we were to guess at it, right, the understanding's not there, like the fundamental understanding, until we go through that part of the book. And I feel like it would be cheating myself out of the knowledge, and you know, I wouldn't be providing any useful knowledge to you because I'm just guessing at it, right? So yeah, let's just do this. I'm going to create a main function, and we'll just return the unit type, which we don't even really need to do. Just leave it blank. All right, so we're going to skip this one. We'll come back. We'll come back to that once we've done some thread work. But yeah, I think it would just be misleading if we just kind of guessed at it. All right, on to the next one. Using as. Okay. Using as. All right, so this is called conversion. So I think we're converting things to different types and maybe typecasting a bit. Typecasting in Rust is done via the usage of the as operator. And we've seen this before. We have. Please note that the as operator is not only used when typecasting, it also helps with renaming imports. We've seen that. We have seen that. The goal is to make sure that the division does not fail to compile and returns the proper type. All right, so let's take a look at what's going on. And we have some tests here to go off of. And we're familiar with this stuff, which is nice. Let's see. So we have an average function, a main function, and a test. So first, let's look at what our tests are testing for. So test returns proper type and value. Assert equals. So it's asserting that a call to average, passing this vector, passing a reference to this vector. All right, in this case, it's just an array, right? Passing a reference to this array, equals this. So it's asserting that this is the average. So we have a function called average. And we also have a main function that also calls our average function. So what does the average function do? It takes a mutable array of signed 64-bit integers, 64-bit floats, and returns a 64-bit float. Great. Okay. Then what it's doing here is it's saying let total equal values iter fold. Again, we used fold last week. So fold is like very similar to something like reduce in other languages, or you have sometimes you have fold left, fold right, right? So it's going to fold over those values. And then we are dividing it by the length. So just an average. And fold is a great way to compute an average because it's a great way to sum a list, right? So let's see what the error is. No implementation for F64 usize. So that's because values.len is a usize. And we can probably see that if we, I don't know why my thing's still not showing my hints here, but values.len is going to be of type usize. And you can see here the trait division is not implemented for F64. We can't divide it by a usize. So let's try saying that we're going to treat this usize as an F64. Awesome. So there we go. What did we do? Let's go over it. Toledo Albert, my man Albert in the chat. What is up? Happy to have you here. Albert's a good buddy of mine. We work on projects together, some of which you might hear of soon. Thank you for stopping by. So here what we've done is we have our average function. It was complaining because it couldn't do division here. Why couldn't it do division? Because this is of type F64 and this is of type usize. Whenever you get a length of an array, it's going to be the usize type. And so what we're doing is we're casting it to an F64 so that division is possible. So now that we're all done with that, we'll comment that out and move on to the next exercise. All right, this is called from into. Open that up. All right, from into. So for from into, we have the from trait is used for value to value conversions. If from is implemented correctly for a type, the into trait should work conversely. So if from is implemented for a type, the into type should work conversely. Pretty cool. So we have here a person that has two properties, a name, which is of type string, and an age, which is of type usize. It's like the usize of a person, right? We implement the default trait to use it as a fallback when the provided string is not convertible into a person object. So we learned a little bit about default traits, right? Or default implementations for traits. So the default implementation for person is going to be string from John. So that's as a fallback, right? So we have John as if you create a person, you get a default of John. Your task is to complete this implementation in order for the line let p equal person from Mark to compile. Please note that you'll need to parse the age component into a usize with something like for.parse usize. The outcome of this needs to be handled appropriately. So there's a few steps. Step 1, if the length of the provided string is 0, then return the default of person. 2, split the given string on the commas present in it. Okay. Extract the first element of the split operation, use it as the name. If the name's empty, return the default person name. Extract the other element from the split operation into a usize and use it as the age. If while parsing the age, something goes wrong, then return the default of person. Otherwise, then return an instantiated person object with the results. All right, that's a lot. We'll do it one at a time, right? Let's take it one step at a time. So we have the implementation of from. And so from is going to convert a string to a person. So this is the function where we are going to write. But before we jump in and write that function, let's take a look at these assertions. Because again, these are the steps. They're each going to be listed out here in the assertions. And we can see we have a main function as well. Excuse me. So for the main function, we have a P1 person. We're creating a person from Mark, right? And it says up here, step 1, we have to get that line to work. In order for the line to compile, please note you'll need to parse the age. So we got to make that work. Since from is implemented for person, we should also be able to use into. All right? Into doesn't exist yet. I think we'll have to code that. And so we have person from, a string, and we can do a string into a person. Okay. And then we're printing that out. Here we have our test. So the default case, if DP person default is created, we have to cert equals, the name is John and the age is 30. So that's our default person. That's here, right? Bad conversion. If we pass an empty string, we want to assert that we just get the default, right? Good conversion. If we pass a name, comma separated with an age, we get Mark 20. So we get that exact value. If we pass an issue where the number, in this case, cannot be parsed to a usize, we ignore it and we leverage the default value. If just a name is passed, we leverage the default value for both the name and the age. And if a name without a age is passed, we leverage the default value. So basically, if any input is invalid, we're leveraging the default value there. All right, so we have a lot of tests to get to pass. Let's see what we can do. So, all right, first things first. From person. So our default is here. We're implementing it here. Let's see really quick what our first error is, because that'll give us a little hint on where to start. Expected struct person found unit type, because our code here doesn't return that. So, okay, so what I'm going to do first is I'm going to just default to having the same logic. So we'll get a different error message. So now it compiles just fine, but our test fails. So a few of them succeed. That's because we're just doing the default. So all the ones that expect the default are going to succeed. But the other cases do not. So we have to get those to pass. So our failures are here. Test, good, convert, standard out, right? So it should be able to handle these instances. So let's start with the first one. Step 1 is, if the length of the provided string is 0, then return the default of person. So we can start out by doing a match. And remember, s.len is going to return a usize. So if it equals 0, and again, we don't need these parentheses here, we'll return person. All right, so we'll have our default here, and we'll just return default. And here we'll return default. All right, let's see. Oh, expected unit type found person, found struct person. So we need to do that. Oh, and we're in a conditional, so we'll return that. Cool. All right, so our tests are still failing. Let's take a look at the first failed test. Good convert. So good convert is a name, comma separated by an age. So we're gonna have to split this string. So let's first look at our docs and see how we split a string. I'm sure it's just a split function, but it's always good to check. Rust string split. There we go. Let's go to our string. Go here. We have macros, keywords, split. Split. It takes self and pattern, an iterator over substrings of this string slice separated by characters matched by the pattern. The pattern can be a string, car, or slice of cars, or a function or closure that determines if a character matches. All right, so let's see what that looks like. It's pretty straightforward. We call split. In this case, we're collecting it into a vector. We can do that. That's fine. So let's do that. We'll call it parts. We'll say let parts, and we'll make it a vector of strings. And again, calling collect will, if calling collect, remember calling collect? Who knows that? You have to be old to remember that. But so by specifying that it's a vector, when we call collect on the split, right, it's going to infer that the type is vector, and it's going to create a vector for us. Otherwise, we could specify it on the collect itself. But so we're going to do s.split. We're going to split on the comma, right? And then we're going to .collect. Now we have a vector. We can do some other checks, though, before we do this, right? So we can move this down here. And we'll clean this code up after we get all the tests to pass, TDD style, right? We'll get the tests to pass, we'll refactor, and make sure we don't break them. So we'll start out writing it as simple as possible. All right. So if s.len is 0, return default. Otherwise, we can do, we're going to split it up by its parts. And what we'll want to do is we'll want to do a check on how many parts there are, right? So we want to check that the len. So if parts.len does not equal 2, we can also return the default. And so let's make sure we still have the same amount of, oh. Check that that works. All right, so we're still good. We're still failing good convert, but everything else is still good. So okay, 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 okay. See that? We just had the one failure, so that's good. So we're still on the right track. Nothing has changed in our code here. All right. Now, if it's equal to 2, so we almost want to do like the reverse, right? We always want to turn default unless we have a certain scenario. And so when we refactor that code, it'll look a lot nicer. So what we can do is we can do, let's flip this around really quick. Say if it equals 2, then what we'll do is we're going to try to grab each piece, right, and convert it to the proper type. So what we'll try to do is we'll say person. We can try it this way to start. We can do name string from parts 0. We can just grab it like that, comma age. For now, this is going to make some of our tests fail, but we're just going to do string from parts 1 just to see what it looks like. And we'll return that. Expected use size, found struct string string. That's for age. So we will do dot into. So what we need to do here is there is actually, it gave us a little thing here we can call dot parse, and we want to parse the use size. Parse it into a use size. So let's see what it says now. Expected use size, found enum standard results. And that's because the parse could fail. And that's why we need to handle it as, it gives a result type. So what we can do is we can say, let age equal and we can either do a case where we can either just, normally we do the question mark, right? We throw the error back. And then what we could do is in our main function, handle the error, but we want to handle it here where if there is a problem, we want to make sure we return the default. So what we'll do is we'll just do a check here. So what we'll do is we'll do match. And if we get okay with the, we'll call it age, we'll declare an age for now. We'll say age equals 30, which is the default. We'll let age equal, and here we'll grab parsed age, and we'll just say age equals, well, actually, this is an expression, so we actually can just set it equal to age, I believe. Let's just try this for now. And again, we'll clean all this up once we get the test passing, because it's kind of messy right now. And the other case we have to handle, of course, is if there's an, since it's a result, it's either good or bad. And if there's an error, we want to just return the default. And so for that, we can just do we can do 30, but what we actually want to do is, because this is just parsing the age, let's go ahead and yeah, let's go ahead and just return default. And let's see what is happening now. Okay, on line 56, we just have to solve for this. Let's comment this out for a second. Okay, so we have parts. We have our parts we split up into a vector of two things. We have our age, which I said is 30 by default. We then try to match on the parsing of usize to see if it's successful. If we get okay in the age, we're gonna set age to the parsed age. If we have an error, we're just gonna return default. And so let's save that and see what happens. So here it found the unit type, implicitly return unit type, and its body has no tail or return expression. So let's look at what's going on here. So we have no return, and that's because we commented out too much. All right, so now we have more that failed, which is actually what we want, right? Because we want to get into some of these cases. So test missing comma and age SD out. Test missing comma and age, panicked at index out of bounds. The len is 1, but the index is 1. So here we're actually accessing an out of bounds index. So what we can do is we can do a check here. So we say if parts, this is where our check here comes in actually. So we can do, copy this in here to make sure we have our correct code. So here what we're doing is we're first checking that we have two values, right, before we try to do the parsing. Oh. Move that in, move that in, move that in, move that in. All right. So here what we're doing is we're just checking to make sure there's two before we try to parse that age out. So now we have just one failure again, and it's probably that the good convert. Okay, so the good convert's still failing, and that's because we still haven't handled the name in this case. In the good conversion part, we still haven't handled the name. So we set the age, and then here what we'll try to do is we'll return person name string from parts 0, which would be the first part, which would be a name. And then we'll return age, which comes from age. And I believe we can just do this. And we're in a conditional, so we'll return. All right, closer, we still have one failed test, but it's for good reason. We have the test that fails when we're missing the name. So what happens if the name is missing, right? We want to return the default. So that's the case where part 0 is an empty string, right? So here we can do a check, right? We can do this. This is handling our age, but next we also want to do a check if parts 0. We can just explicitly check for the empty string. Then we're gonna just return default, and we're gonna clean this up a lot, don't worry. All right, so we passed our test, but very messy code. So let's refactor. And this is the TDD portion, right? We're about to do the chapter on testing in the book. So what a better topic to cover. Let's clean it up. Why do we want to clean it up? We got it working. Well, because part of TDD is getting the code to work and get the test to pass, and then going back and refactoring your code. And the beauty of having the test there is I know that whatever change I make, if I break my tests, I made a change that's bad. So it's going to allow me to refactor my code while leaning on those tests. So what we can do is let's take a look at our flow here and see if we can clean things up, because we have a lot of our logic nested here, right? So maybe there's some early returns we can do. So we know we have our default. And here we have our default person, and that's for when we haven't implemented it. We implement the default trait to use it as a fallback when the provided string is not convertible into a person object. So there should be a way to use the default, and I believe to do that I can just return a person. Let me try that really quick. So instead of using default here, I think I can let's try it. Let's see if we can just get rid of this and return person. Got some parentheses to remove. Where? Ah, here. And we have to use the struct literal syntax, so let's try this. I think we can do maybe person default, I think is what we want. There we go. Person default is what we want. We're going to return the default person. Here, we got to do this. And here. Awesome. All right, that's step one of our refactor. We got rid of this default up here, so we can get rid of that. But there's a lot of cases where we're returning person default. So let's try to remove some of those cases, and we'll kind of just allow the actual parse successful person to be returned only if parse successful. All other cases shall return default. So basically we have if parts len equals 2, right? And then we can do end parts 0 does not equal empty string. We can just jump ahead and do this part. So now this is handling the case where it doesn't equal empty string. So let's see if this is still good. We're still good. What do we do there? I just got rid of this check by just doing the check in advance. So I just do the check up here, and we only enter this conditional if it doesn't equal empty string, part 0, right? What are we doing next? So what we can do next is we want to do our match on parts 1 parse. So we try to parse it. But what we can probably do is we can, well, this match looks okay, because what we're doing is we're saying, okay, parsed age, we're setting age to parsed aged. Otherwise, we're returning this. I wonder if we can do the assignment here. Let me try something really quick. Good, so that works. So what do we do there? Well, we assigned age to parsed age in the OK instance. If there's an error, we're returning the default. So what do we do there? We just got rid of our mutable value. We don't need it. We're just going to use match, because again, match is an expression. So we're going to use match to actually return that value, and that's pretty awesome. And so we're just going to say parsed age there like that. All right, so that's another little bit better, right? Okay, what else can we do? So another thing we can do here is we're returning person default if there's an error. What if instead of that we just do something like, actually I don't mind the return person default. Also, let's see if we can just do this. I wonder if we can just have it jump out to here. Well, let's see. Let's try flipping it around a bit. Here we're doing if s.len equals 0, return person.default. So that's good. We could add that check to here. So we could get rid of this and do s.len equals 0. Or if it does not equal 0, right? Oh, that should be end. So that'll also work. But again, a lot of the bulk of our code is nested. So we can flip this, right? So here we have the bulk of our code still nested, but we do have this nice default return. So we could flip this so that the bulk of our code is not nested. And what I mean by that is we can move this part out, right? So we could do something like move this part in, which creates a little bit of a nice, oh, what did I do? And so what this is going to do is allow us to have the bulk of our code not nested. And what's nice about that is it's a little more readable, I think. So here what we do is if s.len equals 0 or parts.len does not equal 2 or part 0 equals empty string. And so this needs to be a return because again, we are inside a conditional, so we'd have to do the return there. What's going on? There we go. And there we're good, we're passed. So we cleaned that up a little bit. It's a little more readable, right? So we have our parts where we collect them into a vector. We check if we have length, if we don't have length, or we have length but it's not 2, or we don't have a first part after doing the split, or it's empty string, we'll return the default person. Otherwise, we'll try to parse that age. If it fails, we'll return the default person. And in the end, what we're going to do is return our default person. And the cool thing about this is we can actually get rid of our return and use the implicit return in this case. And there we go. So a much cleaner version. I'm sure we can simplify it more if we wanted to. But I think this is pretty good. The only part I'm not like extremely happy about is this. But even in that case, it's not terrible. And we could also make our person mutable and just simply mutate the person and then return them in the end. What I mean by that is instead of having returns strewn throughout your function, what we could do is we could say let mute p equal person default, right? And then we can update that person. Or we could do, here we could just say error return p, in this case of an error. And then here, instead of returning p, we could say, we could just do something like well, here we wouldn't really need to do anything. We just finish the function. And we basically would modify p if we wanted to, but in this case we don't have to modify p, so we could just return p. But I think it looks nice with the default. But yeah, we could definitely do some stuff to simplify it, but I think for now this is pretty good. I think what we could probably do is just The thing that's weird is I'm not sure how to exit early from this to not do the return right here. In this case, the exit early works because we could put this, in an else, but I think this works pretty well. So awesome. So that was a little TDD of this one. So now let's move on to the next one. Let me save it, make sure it still works. We can get rid of this. All right, so we're all good. All right, so I'm gonna delete that and we'll go on to the next one. If anyone has any questions, feel free to ask them in the chat as well. Happy to do my best to answer any of it. All right, so what do we got here? So now we're on to try from into. Let's check that out. Try from into. Okay. Try from is a simple and safe type conversion that may fail in a controlled way under some circumstances. Basically, this is the same as from. The main difference is that this should return a result type instead of the target type itself. Okay. Before we return to person, before we return to person no matter what, in this case, it should return a result type. Pretty cool. Okay, so let's see. We're importing try from and try into, where we have our structure color, which we've derived debug and partial equal. All that means is we're going to have those traits, right? We're going to be able to debug, which means we can log it out with the question mark colon, and partial equality means we can actually do comparisons. So pretty cool. All right, so your task is to complete this implementation and return an okay result of inner type color. You need create, we have to maybe PR for that. You need create implementation for a tuple of 3 integer, an array of 3 integer, and a slice of integer. So you need create implementation for a tuple of 3 integers, an array of 3 integers, and a slice of integers. All right. Note, this implementation for tuple and array will be checked at compile time, but slice implementation need check slice length. Also note the chunk of correct RGB color must be integer range 0 to 255. So then we know we're using an unsigned 8-bit. Okay. Here's the tuple implementation, array, slice. Okay, so let's take a look at the tests and see what we're looking for here, and that'll give us kind of a clue as to what we got to do. So we have tests here. Test tuple out of range positive. Assert color, try from, and it's giving us values, and it needs to assert that that's an error. Here we're gonna test tuple out of range negative. So these negative numbers are also out of range. So we know we're dealing with unsigned 8-bit. Test tuple sum. So this is also gonna fail. Test tuple correct. Result color C equals, it's going to take this tuple, it's going to try into, and it wants to get a result of color string. So result is, what does this mean? Result is generic over types color and string. Color is what the okay response will return. String is what the error will return. And then we're just asserting equal that C is of type okay with the color. Test array out of range positive. Okay, so some basic tests. All right, so let's see what we need to do here. Our main function uses the from function to color, and it's going to call try from these values, and it's going to print it. Since from is implemented color, we should be able to use try into. So that's try into. So it's the same thing as try from, but just different syntax, right? It's operating on it. Kind of like what we do with copy. And string from, right? And so this is hoping we'll get a color with no error here. Here we have a vector. With slice, we should use from function. So color try from, pass it the vector here. Or take slice within round brackets and use into. So cool. The vector is of length 3. So these should all work, right? And so right now, what is our error saying? Right now it's saying expected enum standard result found unit type. So we have to implement our try from. And here are the 3 different implementations. We have try from for a tuple, We have try from for a vector of length 3 and try from for a string slice. Okay, an array, sorry, this is not try from. This is try from an array of signed 16-bit integers. And right now, let's see what it's doing. So here, type error equals string, okay? And then it's function try from, and it's supposed to return type self or self error, because error is type string, so that's a good return type. We have to implement it. How are we gonna do that? Well, what we can do is we can say, let's see, how are we gonna handle this? So we have our tuple. So what we can do is we can say, let red, green, blue equal tuple, and we can try to do color, right? Red, green, blue. And now this might fail, right? This might fail. So if it's successful, we return OK in this. If it fails, we return the error. So just doing this, right? These are unsigned 8-bit integers, so they're supposed to be of a certain type. And so we have 16-bit integers here, right? And so this may fail. So what we need to do is try to convert these. And if that fails, then we have trouble, right? And it says it here. Your task complete the implementation, return OK result. You need to create implementation for a tuple of 3 integer. Implementation we check to compile time, but slice implementation needs to be checked. Needs to check slice length. Okay. So we need to check that these can be converted to unsigned 8-bit integers. So how do we do that? We have red, green, blue. I think we can do let's see what happens when we do this. So if we just were to do this, right, you're just going to get issues because right away we're not returning a result. But even if I wrap this in OK, right, because these have a different type, that's going to be a problem right away. So let's check out the error there, and it should give us some hints. Nope. First we need to do this. Throw in a semicolon. Woo. All right, let's see. So here we have an error, expected U8, found I16, right? So it says here, you can convert an I16 to an U8 and panic if the converted value won't fit. Check this out. Thank you, Rust compiler. Always popping out, coming out with the hints, right? Hitting me with some hint jabs. It's like, oh, you want to know how to do it? Right? And this is great. I love this. Look, and what is this going to do? It's going to panic if it won't fit. Well, I don't want it to panic. I want to catch that, right? And I want to leverage that to return an error. Right? How are we going to do that? Let's try it. Let's see. All right, let's see what this is going to look like. Because we don't want it to panic. We want to try it. So let's see what we can do here. Let me just do some searching. Convert I16 into U8. Rust, obviously. Okay. Let's see. From U8. So do we have a from I16 on U8? Let's see. From Nope, it doesn't make sense because I16 is bigger, right? Eights. Assert equals. Let's see what we can do here. Let's look at our list of functions. What is the one they want us to use? So they're telling us we can do try into. Okay. Let's do that. Let's try that first and see what happens when it panics. I wonder if we can pass that along. Let's try with that first. Let's see what happens. All right. Line 41. It's saying here that, okay, color. All right, so nothing happened here. Oh, that's for this other one. So do we not get an error on this one? I'm a little surprised that worked. A little surprised. A little surprised. Let's keep going. Let's keep going. Let's keep going. Because I'm a little surprised that that worked, only because I know there are instances, I guess it's just because we're not able to compile. So once we compile, the test will fail, obviously. So let's just get this thing to compile. So here we have an array of 3 16-bit integers called array. So if we just did the basic, definitely not going to work version of this, it's essentially self. Oh, and here I was using color, but I guess I could use self. Is that gonna work? Yeah. Okay, so then here what we can do is red, green, blue. We're gonna do the same thing, essentially. We're gonna do essentially the same thing, but with the index for now. I'm sure there's a better way to do this, but obviously we'll get an array out of bounds if there's a problem. Although this can only be called with something of like 3, so that's good. All right. What do we got going on here? Line 42. All right, so we should be good there. Save that. Okay. There should be one more. Yep. String slice. So the string slice, there is a little hint up here that said, note the implementation for tuple and array will be checked to compile time, but slice implementation needs check slice length because it is not going to check it at compile time, right? It's not specifying a length. So we can do here, if slice.len does not equal 3, we can just go ahead and return an error. Slice of length 3 was not provided. Right, and we'll just return that. And then if otherwise, we'll just copy something very basic from here. And it's gonna be the same thing, but it's gonna be slice. Whoa. Yeah, so here we'll just do slice. Slice. All right. Pretty good. Let's see what's gonna fail now. I think we're in a weird state. Let me just cancel this and run it again. Look at all the stuff we did. Look at all the stuff we've already done. So cool. What time are we at? Oh, we're good. We're good. We might finish. We just might finish it. Let's see. All right, let's start from the top. Cannot find function tuple struct or tuple variant error in this scope. That's here. Self error. There we go. All right, now let's see what else we got here. Unnecessary parentheses, we can get rid of that. That's easy enough. That's here. But here, let's see. Error not found for this. Associated item not found in color. So we'll need to do, I think we just have to return error, right? All right, there we go. Expected struct string found string slice. So all we need to do here is just string new. Sorry, it's string from. Or we can do toString, remember. All right. That's that. Expected struct color found enum standard result result. Interesting. That's on line 114. Let's see what that's about. Color try into. But it got an enum of standard result, but expected a color. Well, it's not going to get a color because we return a result. Let's see what it's talking about. So it's not going to get a color because the return type of this is, of course, a result. So I'm wondering if we have to implement try into as well. No, it's a result color here. So here they're expecting result color. And here they're asserting regular color. I wonder if this is a issue. Oh, is this one not expecting a return type of... Oh, it might be that this one doesn't expect a result return type. Let me check. Yeah, this one just expects a color, not a... No, that's not right. It expects a result. So, sorry, I'm just looking at the return types here. I'm talking to myself a bit, talking to you, though. And I'm wondering why all of a sudden these are expecting color from try into, and this one randomly expects a result. Oh, it should. Oh, asserts is error. So that's right. Yeah, this is odd. Anyway, let's see. Well, it's okay. We'll want to give it an error. This should obviously fail. And it's not. Although this is super weird. Yeah, so it looks like all of these are failing just because of this reason, which is odd to me. Anyway, let's see. No method name is error found for struct color in the current scope. Do we need to write this part? Let's see if there's anything that's saying we need to write this part of it. So it says, complete this and return an OK result intertype color. You need to create implementation for a tuple, 3 integer, and an array. Note the implementation for tuple. An array will be checked at compile time, but slice. So we did that, right? Try from is a simple and safe conversion that may fail in a controlled way under some circumstances. Basically, this is the same as from. Main difference is that this should return a result type. Yeah, so I don't get why. Do we have to implement try into, I wonder? It doesn't say that we have to do that. Yeah, and look, here it's expecting result color. Are these tests just wrong? Are we allowed to change them, I wonder? Yeah, like this looks wacky. This looks very wacky. Because, yeah, this is odd. What I'm going to do is I'm going to change these really quick. Because it looks like these are just wrong. And we may have to submit a PR here. I'm going to go ahead and just adjust these. There we go. Okay. Interesting. I don't know. Maybe it's just it could be that the Rustlings is wrong. I could also just have an old version. I don't know. We'll have to mess with it. We're still getting failures though. And it looks like because we're panicking, right? So what I want to figure out, and we've done this before, is I want to catch them. So standard panic module, which includes methods for halting and unwinding process, starts by panic. So if we have a panic, I want to catch that. So this looks like I might want to use this. So we have result, panic, catch, unwind. Result is error. So let me see. Let me try looking this up again. Convert Rustlang result. So let's see. Convert try from. I guess we ourselves can use try from. Right? We could probably use try from on our color. Yeah, let's try that. Let's try that. Let's see if that doesn't. Let's try that actually. What if we did red? So we're going to use, I'm going to try using try from. And the reason I'm thinking about using try from here is because if try from returns a result type, we can leverage the error and just pass that along, and then we'd have our error. So let's try doing this. What I'm going to do here is I'm going to say U8 try from red. And I'm going to do it up here. I'm going to do it like this. I'm going to say let's do let red equal U8, or we can do try. Oh, we are already doing try into. So why do we need unwrap? What if we got rid of the unwrap? Then we should be, if we got rid of the unwrap, we should get the error. So let's try, I want to try something really quick. Let's try getting rid of this unwrap. First, I want to look at what try into returns. So I'm pretty sure it also returns a result. Yeah, so let's just get rid of the unwrap and see if we can use our question mark . And we're going to try into U8. So let's see what happens there. Standard convert from try from int error is not implemented for string string. Okay, let's try this. Let's see what it's complaining about exactly. Expected value found built-in type U8. Not a value. Oh. So we have to say U8 like this probably. Or actually, we could probably let it infer it. So let's just get rid of that, right? Ah, okay. Let's see what's going on here. The trait standard convert from standard number try from int error is not implemented for string. The question mark operation implicitly performs a conversion on the error value using the from trait. Ah. So what we actually want to do here is, and implicitly performs a conversion on the error value using the from trait. So we don't want to do that. I think our fix here is to, let's see how we were using, I think, does it go before? I forget. I don't think it goes before. What I'm going to do is I'm going to take a look and see how we used it before. So we used it in, where did we use it? We used it in our result type. Let's see if we used it in any of these. Let's pull it up here. We definitely used it in here. Let's see. Unwrap. All right. Here we have while open. Let's see, where's our question mark? Here we have this. Oh, is it because I forgot my, is it just because I forgot my semicolon? That's possible. Let's see, what am I doing here? Let's try this. We'll do, I'm just going to try this really quick. Let R equal red dot try into and we'll see if we can do it this way. So basically what I'm trying to do is I'm trying to, instead of getting this to panic, my idea is to get it to return an error type, and I'll just return that up using the question mark. At least that's the thought here. Let's see. Yeah, so there's something wrong with this problem. It's not letting me do that. And so I'm wondering, let's try something different. Let's try, let's do U8 from, well, actually we want try from, right? Try from, let me see. No, it should be try from. All right, let's try this. U8 try from red. Let's see what that's going to say. Expected U8 found standard result. Okay, so we're getting closer. Let me just copy this for these. Well, let's see what happens. So here we're trying to, again, we're trying to convert these into, we're trying to convert these 16 unsigned, these signed 16-bit integers into 8-bit integers. And what I want to do is I want to try to convert them. And if there's an error, I just want to bubble that error up because this is going to return a result type anyway. So I can just bubble that error up, or I can do a match and do something with that error. It might be, the issue might be that I'm not returning the correct error type, which is totally possible. Which might actually be what our error is saying here. Found enum, where it's saying implicitly performs conversion on the error value using the from trait. So it might just be that I'm not returning the right error type. The trait standard from try-int error is not implemented. So this actually might be the problem. It might be that we had the correct code there, but we're not using the correct error trait. So we'll try modifying that with a match. Okay, so let's try this really quick. See if we get a similar error. So here we have to return a result. So let's return a result. Got it. Okay, so we had the same thing, and that's because the error type for this try from is not going to be the same as error string. So what we can do is we can use a match here. So what I can do is I can say r equals match. And we can say okay value, and we'll just return the value. Otherwise, if there's an error, we'll catch the error. We don't actually care what it is, and we'll return what kind of error do they want us to return? Does it say? They don't care what the string is. Okay, so we'll just say invalid value supplied. And we'll basically do the same thing for these three. Let's just copy this. Get rid of this. And then we'll clean it up after. So here we're gonna do green. And we can even say here invalid red value supplied, invalid green value supplied. Or we can actually probably get the error string from the. So Matt said, do you need to take the lower bits explicitly? If you get a number outside the range of U8, then you return an error. Yes, are you referring to this part? Do I need to explicitly grab it here? I think because the match is an expression, I do need to do that. My intent was to just, if it fails, return the error back up. But because the error of the conversion is not this type, it's not of type error string, it wouldn't let me bubble it up. So what I'm doing here is I'm trying to capture the error and then just provide a string. This is blue. Does that make sense? And blue. All right. Yeah, I mean, I could just check the range of the number, if that's what you're thinking. Like, just check that it's out of the bounds. But I feel like the point is to try converting it, but let's see. So let's do blue, invalid blue value, supplied, and then we'll return that. Get rid of this. Oh. I gotta do this. And it's supposed to be a string, so we gotta do .toString. Let's pop that down here. .toString. All right, let's see if that's gonna cut it. Expected U8 found enum standard result string. This is found to be of type U8. Yes, we know that. And then it says here error expected, because I have to explicitly return the error. Duh. So here I need to return this error. And there's definitely an easier way to clean this up with the question mark. We just have to figure out how. Oh, and we have to add semicolons, of course. All right, cool. Still have some failures, but let's see if the tuples passed. Tuple passed, tuple passed, tuple passed, tuple passed. All right, so we're good on the tuples. So let's see if we can simplify this a bit. So we have a match expression, and ideally I'd like to bubble up the error. Patatas is back. Patatas del Papa, always coming through. So Patatas, we're working on the try from into. We're doing some funky stuff, but it's coming along. So here what we're gonna do, let's see, let's walk through this, see if we can simplify this. Actually, so first, before we do that, let's kind of copy what we have here and move it down here. And just try to get this to pass. And then we'll clean up everything, test-driven development style. And so here, instead of red, we're going to do ARR 0. And we can do this, right? Because we know at compile time this has length 3, which is different than the next one where we don't know. Beautiful, beautiful. All right, let's see. Good. All right, we passed all those. We have 3 failures for the slice. Slice of life. Okay, so let's grab the slice. Let's copy our logic here. Don't worry, we'll clean it up. Don't you worry, friends. Right, we can just move this. Okay, so here. If it's not of length 3, we got to return a error, and I'm just going to go ahead and switch this to a toString just so that we're consistent. Be consistent. Ah, yeah, Twitter can be bad. If you follow, you've already followed this stream, but you'd have to set up notifications on Twitch to get notified that way. But no worries, we're happy to always have you. You know, you live your best life. You can always catch up on YouTube. And just appreciate you stopping by. That's awesome. So here, if it's not of length 3, we're going to just go ahead and ditch. Otherwise, we're going to go ahead and try to grab not ARR, but slice, right? And for some reason, my multi-cursor select is not working. All right, let's go ahead and give this a run. All right, so we passed, right? But it looks, we got a lot of code duplication, right? We can clean this up. So let's do that. Let's look at what we have here and walk through what we're doing. So at each step, we're trying to convert an I16 to a U8. And the beauty of the conversion is the conversion will actually return a result type. And we can leverage that result type to do some stuff. And what we originally tried to do was using the question mark, right? We said, if we get the value, get the value. Otherwise, if it's an error, just bubble it up. The problem with that, though, is the error type from that conversion, unfortunately, wasn't a string. So we weren't able to leverage that. What we could do, potentially, is box it so that all errors that come out are of the same error type. We've seen that, right? So that would look like, let me see, I believe we did that in errors 3. Or maybe it was errors n. Yeah. So what this allowed us to do is we caught all errors and returned a single type of error. So what that would look like in our case was self error. And so, oh, not found in self. Duh. I gotta do. Sorry about that. Let's go back. So we have self error, boxed in, self. Wait, what is it saying here? Not found in self error. It should be found. Oh, I can't do this because it's got to be in this case, I have to use a built-in generic error type, but I don't want to do that. So what if we did, I wonder if I can do error string. I guess not. Well, I wonder if we can just do string. Nah. I tried. Not gonna work. All right. So next attempt here. It needs to return self.error, which is of type string. So what we can do, if we're not supposed to change, I don't think we're supposed to change this. Let's see, does it say that we can't change it? It doesn't say that we can't change it. So we could change it. We could say that the error type is not a string, but is of type this, right? We could say it's like this. And then we can say right? But now it's saying a built-in type with a similar exists. Oh, wait, what? Where did I-15 come from? Get out of here. How did that happen? Let's see. And then we just had to pull in this module. Right? Like we did here. Here we're using error. So we could pull it in. Let's pull it in. So let's go ahead and pull it in. Let's do okay, no, it is expecting a string explicitly, right? Okay, so we don't want to do that. So let's see, how can we clean this up? Well, if we need to, let's convert one of these back and see what the error is, and it'll be a little more clear. And the way I'm going to do that is I'm just going to get rid of this and put a question mark and see what the error is. What is it saying here? I don't need the match, that's why. Let's see what this says now. All right. The trait standard convert from try from int error is not implemented for string. So the error that this is returning is standard convert from that. It's that whole thing, right? And so it's not going to be a type string. So the question mark operation implicitly performs a conversion on the error value using the from trait. So it tries to convert it to a string so that we can return a string error. Help. The following implementations were found. String as convert mute string. No, required by string convert from. So we're not able to convert this error, which is basically why we did our match statement and explicitly returned these values. Now I'm wondering if there's a way to convert this. Let's see. Let's see if we can do anything with this here. Let me run that again. Because that would be a lot nicer. If we could use the question mark, it'd be a lot nicer than using the match statement all over the place, right? This looks a lot cleaner than this. And then we can just actually do this in line down here and we'd be good. So let's see what we can do. Because we also have a lot of duplication, right? Which is not ideal. I mean, we could move these out into their own functions, but where we're doing this repeated work here, we can move this out into a function because we're doing it over and over. The only difference here is how we're accessing the value. But other than that, it's the same. So let's see if we can do this. Like, let me just search this. Wait, let me copy that, get out of the way. Why is my copy paste not working? All right, let's see. Unable to use as the default error my type from invitation is. All right, let's see. Is a tuple struct with private fields. The type doesn't expose way to construct an instance. Not very useful for us. So Patatas said, are you trying to implement foreign trait to foreign type? Remember orphan rules. And he posted a post here. Thank you for posting the exercise, Clam. Basically what we're trying to do, Patatas, is I'm trying to clean this up. What we're doing here is we have, I mean, it works perfectly fine, right? Everything passes. It does work. But we're trying to use that TDD to get this a little bit cleaner. Because right now it's kind of messy and we have duplicate code. So what I would like to do is, instead of using a match for each of these, this try from already returns a result. So ideally I would like to bubble that result error up, but unfortunately the type of this has to be a string, right? The error type has to be string. And so since the error type coming out of the try from is not of type string, then it won't work. Exactly. So Patatas said there's no way to implement from for errors. So another thing we do is we can just clean this up and just have it so that we pass some values to a function. We pass the 3 values and it does the conversion. So let's do that to make things a little simpler. So what we can do is we can say we could do something like this. Function get, what are we getting? Get color from values. And what we'll do for get color from values is we'll take 3 values. We'll take we can do a tuple, or we can just do, let's just do RGB. And what we're going to do is for R, we're going to say that that's an I16. This is an I16. This is an I16. And our return type here is going to be a result of type self. Well, actually, in this case, it will be a result of type color, or string. We'll do string. So here what we have is we are just creating a generic function that takes 3 values and returns a result of type color or an error of type string. And so what I can do is I can take out this, copy this here, see if I can get this to work. Oh. Where's my, I want to paste it with my format. All right, let's copy this here. All right, I'll fix the indenting later. And so what I want to do is I can just say match do a little bit of this magic here. For green, we can do the same thing here. So now we have a nice cleaner. And here we're gonna call this G. Oh, wait, we have RGB, sorry. B, G. Oh, R. All right, so we have R, G, and we need B. All right, so what I'm doing here is I'm just creating this function, which is going to return, I actually don't know if this is gonna work well, so what I'm gonna do is I'm gonna say, let's go back to what we had, because I'm not sure how that's gonna work being in line there inside that, okay. So let's stick with this. So we have R is equal to, we're gonna try to grab red, or in this case, let's call these what they are, red, green, blue. And it's going to return our result of either OK color or OK string. So in this case, this is gonna have to be color, right? And so here, what I'll do is I'll simply call our function get color from value, and I'll pass it red, green, and blue. And let's see if everything still passes. Good. So everything still passes there. So what we'll do is we'll copy that code. We'll go over here and we'll call this function and we'll pass it R1, or sorry, R0, our index 1, and array index 2. Save it. Still good. And then down here, we'll simply do the same thing. Call this. But instead of here, we're going to do slice, slice, slice. So there may be a better way to do it, but we've simplified it quite a bit, and we've moved our code out into a separate function that returns a result type color and string. And we're calling it from each place. Taz in the chat is saying, struct my string string, and then implement string for my string. Would that work? I haven't tried though. It would work, but I prefer it to be its own variable and then put that into OK. Yes, I think it makes more, I get it. So yeah, I like it better as its own thing and then putting it into the OK. It's a little more clear than what we had before. So I think this is a little bit nicer. So awesome. So we simplified it quite a bit and it still works. Let's toss away our I am not done and move on to the next one. And we're almost at time, so let's see how many we have left. All right, the next one is as ref. As ref mute. All right, as ref and as mute allow for cheap reference to reference conversions. Read more about them here. So we'll definitely check those out. Obtain the number of bytes, not characters, in the given argument. Add the asref trait appropriately as a trait bound. Obtain the number of characters, not bytes, in the given argument. Add asref trait appropriately as a trait bound. Okay. Oh, so the first one is get the number of bytes. Second one is get the number of characters, not bytes. And then here we have cafe au lait. Print the character counter, print the byte counter. And we have test. Let S, cafe au lait, assert not equal car count and byte count for S. Assert equal car count and byte count for, wait. Oh, okay. It's because of this, the accent. I was like, wait, they're the same. Okay, so these should not be equal because this one has the extra bytes for this, right? Same amount of characters. different number of bytes. Here we have the same count here, bytes and character is the same. Different counts using string. So for string, we want to make sure that it's still the same there, and same count using string. So we need to make this work. What do we have here? We have our byte counter, returns a U size. So here it's doing arg, it's a generic type, as ref, as bytes.len. And here we're doing arg as ref.cars.count. So let's see what's happening. Method not found in T. Right, so we need to specify what type we're dealing with. It doesn't actually say what we need to do. I'm assuming we just need to make it work. Add the asref trait appropriately as a trait. Oh, we need to say that it has the trait. Right, so we learned about trait bounds. Well, we learned about them when we did it here. And so the way that that worked was, I think we actually did it when we did it in the book. But you can actually specify a trait bound to say that T needs to implement a certain thing, right? So, where is it? Asref mute, there it is. Okay, so let's pull up, I'm gonna go over to let's open up our other code base where we have what we learned in our Rust book and see what's in there. Because I know we've done this before. Traits, there we go. All right. This is of a certain type. So here we're saying that T should have display and partial ORed. All right, so let's try using that. So let's say T should have, I guess in this case, T needs to have what? As ref, method not found. So T needs to have as ref. So what if we just did expected one type argument. Wrong number of type arguments. Expected one found 0. So let's take a look at these. All right. Here. We need to say what kind of type. So let's just look at it really quick because it's good to know. Used to do a cheap reference-to-reference conversion. The trait is similar to asmute, which is used for conversion between mutable references. If you need to do a costly conversion, it is better to implement from with type reference of T and write a custom function. All right, so let's try. And as Patah says in the chat, it takes an argument for a type. So let's do it. Let's try. What are we dealing with here? We're dealing with strings, right? Well, actually, string slices. So let's do there we go. All right. Now we have a whole nother slew of issues. Oh, you know what? Let me try. I think I just need that, right? So we got it here. No method asref found on primary T. That's for this part. Asref, str. And we're good. So we needed to say that T implements the asref for this to even work. And we're specifying here that it's going to be a string that is the type. So it needs to support asref for string. Pretty cool. All right. And I think we'll get to that part in the book pretty soon. Next one is from string. Okay, from string. We've done this one for sure. Cow is also the same as cow static cow. Yep. Got it. So you don't need the reference, the ampersand str. Got it. All right, so here what we have is this does practically the same thing as try from with a string does. Additionally, upon implementing from string, you can use the parse method on strings to generate an object of the implementer type. We can read more about that in from string. So here we have from string imported. We have a person with name and age. So this is kind of like the last one. Oh, so we need to solve the same problem, it looks like. It's the same problem as before, where we have a person and we have all these scenarios, and we're just solving it differently. We're using from string here, which is practically the same as try from implementing. Additionally, upon implementing from string, you can use the parse method on strings to generate an object of the implementer type. Okay. So how is this going to work? Let's take a look at what from string is going to do for us. Parse a value from a string. From strings method is often used implicitly through strings parse method. See parse documentation for example. So let's see how they're using it here. They have a point xy from string. This is how they've implemented from string for this function, right? So coords, so they do s.trim matches, so they do some splitting on a comma, and they look for the, because if you're giving a point, you're giving xy, so they look for that. So it's a little bit of matching to get those values, and they try to parse them into I32s, right? And they throw an error, which is a parse int error, because of course they're trying to parse an int, and they create a point. So here we have from string. Okay, what did we call for our person? What did we do? We just implemented a from function. So not specific to string in this case. Whereas here, from string. Oh, so we can use the parse method. I see. Okay. So because from string is generated, parse will work. That's pretty neat. Okay, I see. So basically, if you look at how they're using it, that's the important part, right? So before, to create a person, they were doing person from and passing this, right? Person from, passing this, person from. But because we're implementing it as from string, they're able to do parse. So actually what we should be able to do really is just copy this into here, right? Our implementation can remain the same. Although we do want to return a result. And because we want to return a result type, we're going to want to wrap this in okay. Right? Same thing here. Same thing here. And are they expecting an error in any of these instances? They're expecting a panic. So they're expecting a panic here because they're unwrapping an error. So we do need to return an error. And it probably says it here. Yeah, if the name's empty, return an error. So instead of returning the default, we got to return an error. Okay. So instead of returning the default, we'll return the error. So in this case, we can just do, what type of error do they expect? A string. Okay, so they expect a string error. So what we can do is we can just do turn error failed to parse age. Whoa. And then to string. So there we're returning an error. In this case, we got to return an error. So we'll just do error failed to parse string. All right. And in this case, we'll return this. I think that'll do it. Expected use size found enum result. So that's for this part here. We need to return. All right, so here we're saying we need to, we just got to get rid of this here, sorry. For that, we should be good. Awesome. All right, so we did it. What do we do? All we did was we looked at the difference. So now we are expecting parse. We're implementing from strings so that parse can be used. Parse returns a result. They're expecting panics, and the way that they're getting a panic is they're unwrapping the error, which will give them a panic. So I need to just change the default return type to be to return an error instead of returning the default value. So we just copied over our code and just modified it a bit. So we started by just copying over this code. Instead of returning the default person, we simply return an error of type string. And if it is successful, we return OK with our person. And then they can call it like this. So the important part here is actually the test and how they're utilizing it. So pretty cool. So let's get rid of our I'm not done. Yo. What? Yo. Oh. What is it? What? Look at this. I know we cheated and we skipped threads, but don't talk about that yet. Ignore that. We didn't really cheat. Yeah, we did. So we did skip threads 1, because it was a little crazy. And we didn't want to guess. I want to learn. Maybe you wanted me to guess. I don't know. I wanted to learn it before I could dive in, so I commented it out. But low key, we finished everything else. So pat yourselves in the back if you've been following along. Pat yourselves in the back if you've been helping out in the chat, like Patatas and Clam Watson, killing it in the chat today. We did it. What time is it? Yo, we're only 3 minutes over. All right, so we did it. We finished Rustlings, except for threads 1. But no one's talking about that. No one's talking about threads 1 yet. We're going to come back. We'll do threads 1. But we did it. That was fun. Wow, that was fun. Let's see what it says here. Let's see what they're saying to us. All exercises completed. We hope you enjoy learning about the various aspects of Rust. If you notice any issues, please don't hesitate to report them to our repo. We also contribute your own exercises to help the greater community. Yo, I'm going to write down some of the stuff that we came across while we were doing it. There were some grammatical mistakes. Patatas, I remember you in the chat last week had pointed out another great test case. I'm going to make a list of those, and maybe what we'll do is we'll try to open them up and contribute back. Patatas in the chat said, now never touch async unless you like pain. Yes, once we get to that part in the book, it'll be interesting, but I did not want to try to do it because I felt like if we tried to do threads 1, I might be able to guess at it and let the errors kind of get me there, but I wouldn't be understanding what I was doing. And I didn't want to do that for all of you. Whereas the other stuff, while we kind of didn't understand some of it and hadn't gotten to it, we learned as we went, and it was really cool. So that was awesome. All right. That's going to be it for tonight. Man, we did it. We finished Rustlings. That was super fun. I highly encourage you all to check it out and try it. Go through it again. We could go, I'm not going to do it on stream because it would be boring for a lot of you, but one thing you could do is go back, now that you have this test, it's TDD, go back and make some changes, refactor your code, see if things still pass. Fantastic. Awesome job. That was really fun. Special shout out to the contributors to Rustlings if you're watching. If you're watching, that's pretty cool. But if you aren't, or if you are, appreciate it. As always, if you came in late or you missed the stream or missed the last streams, check out the YouTube. Just subscribe there if you're interested. Don't feel pressured. don't feel pressured. But you'll get updates on when we post new content. We got our Thanksgiving edition where we've been going through Rustlings. We have some one-off stuff there. Check it out. There's a plug-in for it again at the beginning of the stream. But this episode will be up tomorrow, so if you missed part of it and you want to watch it for some reason, I respect you if you want to watch it. That's pretty cool. You can watch it at 1.5 speed, 2x speed. You could slow me down, so I'm really slow. Or you could speed me up like a little bit. It's up to your calls. Do it however you want. But definitely check that out. And again, subscribe for those notifications. Follow on Twitter. Unless you're like Patatas and you can't handle Twitter right now because it's a toxic dump, then avoid it by all means. But if you are using Twitter, follow there and you'll get updates for when I go live. I'll be pushing up my solutions for the Rustlings exercise to my GitHub. Also, all the other stuff is on there as well. So definitely check that out. I want to thank everybody for hopping in. It's been really fun. And as I mentioned in the beginning, we're going to keep this going. We are going to be doing it every Tuesday. Might be adding another day, but I've been really enjoying it. And I want to give a shout out again to everyone who's been subscribing on YouTube and commenting. It's been really appreciated. A lot of fun to see people getting enjoyment out of the videos. Especially how long they are, right? These are long. We're doing streams. We're just putting the streams up. There is the one-off content too, the little short videos, but it's awesome to see people watching it. So appreciate you if you've been subscribed on YouTube and followed on YouTube. Appreciate you if you've been joining the Twitch chat and enjoying the stream that way live. And again, if you want to check it out live, Tuesday nights, 9 p.m. to 11 p.m., twitch.tv/TomMcGurl. You can find it on this page right here. Happy to have you tonight. We had a lot of fun. We finished Rustlings. I will be back next Tuesday, but special shout out to, I'm excited, man. I don't even want to end it. I'm like, oh, we finished Rustlings. What do we do next? What are we doing next? But we're going to end it. We're going to come back next week. So everybody, if I don't see you or you don't watch any videos then, have a happy holidays. It's, we got the holidays coming up. That's why we switched over to the winter theme here, But all right, that's where we'll end it. Fantastic stream. Thank you, everybody, and everyone have a great night.